Good afternoon. So far, you heard the talk from Erica about wide area coverage, 5G/6G, and global perspective of 7, 8, and upper 6. Here, we're going to change gears a little bit. We're going to talk about, the focus will be primarily on the US, and our topics are 3 gigahertz, or lower 3 gigahertz, I should say, and 7 to 8 gigahertz. And much of the focus will be on what's going on in the US, what are the developments, what have happened in the recent past, and what we see is going to happen as best as we can guess over the coming years. We'll talk a little bit about the background, why you're even getting there, and then we talk about the 2 bands separately. And then we'll spend some more time looking ahead what's happening. Again, from Erica, you saw the different use cases and so on and so forth, and I'm not going to go into that. But still, nonetheless, we should have a broader perspective about why are we even talking about these new pieces of the spectrum that you're not using today. So there is, still obviously going to be demand for spectrum. There is traffic growth that we know about, say, 5 times data increase over the next 5 years. That's the overall consensus that we see. That will drive one aspect of traffic capacity needs. But also we have to keep in mind that we're expecting 6G somewhere in the, say, 2030 timeframe. And at the time of introducing 6G, we'll still have 4G and 5G operational. So again, how do we make room to introduce the new technology without affecting the existing technology aside? So we have to look for spectrum where we can actually deploy 6G. There are some estimates from Nokia, Qualcomm that will at least 400 to 500 megahertz channels should be necessary to deploy 6G in day 1. But also another recent activity started in 3GPP. They're looking at 200 megahertz channels. No matter what we end up with, we still have to find out the right kind of spectrum, the right amount of spectrum, and so on and so forth. Now, when we want to introduce new technology, especially for wide area coverage, there are certain aspects that we need to keep in mind. There are some characteristics. And one of the major things is we want to be able to reuse the existing infrastructure as much as possible. And today, the existing infrastructure is primarily dependent on, say, 3.5 gigahertz and below spectrum frequency range. And that results in certain density of the network. And if we want to retain the new spectrum that we're going to use, be somewhere in that close vicinity. But the fact is today, if we look at the US allocations and how they're going to be used, there is not much spectrum available other than, say, the 3.1 to 3.45 that are going to take a deeper dive at. And the next closest one is lower piece of the 7 to 15, or 7 to 8 gigahertz. So that's the reason why you're looking at these 2 pieces of the spectrum, so that we can reuse the existing infrastructure as much as possible. But as we can imagine, these 2 bands have very different propagation characteristics. It's much more challenging into 7 to 8 gigahertz. But along with that, there is also comes some advantages. When you have higher frequencies, let's say from 3 to 3.5 to 7, yes, the propagation characteristics are less. However, we can also pack more antenna elements within the same form factor of the antenna aperture. If you think of, say, twice the frequency, it means half the wavelength, and we can pack, let's say, 4 times as many antenna elements as just an order of magnitude kind of feeling. So with that, we can try to overcome some of the limitations at more antenna elements and advanced MIMO beamforming. We can try to overcome some of the limitations. Of course, it comes with a cost factor and so on and so forth. But nonetheless, there is at least an engineering solution to address at least some of the drawbacks of the higher frequency. And last but not the least, we know both these spectrums have got a lot of incumbency, some more from military and some also other civil applications, but primarily from many government incumbencies there. If we look at what is happening on the supply side, this is more on the demand side, let's say, is what we need. But on the supply side, on the WRC in 2023, we know that 3.3 to 3.4 has been allocated for mobile applications. And also, Erika mentioned that for 27, we're looking at three different frequencies, 4.4 to 4.8, 7.1 to 5.8.4, and then 14.8 to 15.35. These are at the international level, that's what they're looking at. Just before WRC 23, November of 23, the NTIA came up with the National Spectrum Strategy. And here they're looking at, or wanted to look at, 3 other pieces of the spectrum, 3.1 to 3.3. This is primarily used by DoD. 7.1 to 5.8.4 and 37 to 37.6. Now also keep in mind that in the US, 12.7 to 13.25 is also kind of very much considered for mobile applications along with the other existing applications there. So these are the main bands that are being considered. If you look at the 2 pieces that are being addressed in the WRC items and the National Spectrum Strategy, 7.1 to 5.8.4 is the only common band. So from a global ecosystem development perspective that we can take advantage of, this particular band becomes very, very important. Now, what has been going on in terms of figuring out what to do with these 2 bands that we talked about, this lower 3 and 7.8. Last year, there were 3 parallel activities started that we did. Back around March of 2024, we saw the National Spectrum Strategy Implementation Plan, or I-Plan. It was published, and there was a Interagency Spectrum Advisory Council that was formed. They initiated the studies of the 2 bands. Most importantly, it is not just a typical study where, say, FCC or NTIA are involved. It's all the government agencies, I think about almost 16 different government agencies from DoD, FAA, FCC, NOAA, NASA, etc., etc. All those agencies were involved in that effort. And one fundamental consideration that was a part of that effort was that their study would consider moving around federal usage, including repacking, relocation, and so on and so forth. In parallel to that, there's also a PATS 2 study was initiated sometime around, I think, May of last year, May 2024. And their goal was to continue on PATS for the original PATS study. To keep things in perspective, PATS was the same kind of multi-stakeholder group that was being involved, but in the PATS effort, it was never considered that any amount of repacking, reallocation of federal users, that was not a part of the exercise, unlike the NSS implementation plan. And the third piece of that effort was a demo for a dynamic spectrum sharing effort that was also announced. And with the target of September 2025, the demo will be ready. But now I think it has been moved out to November 2025. And it will basically involve the best practices for different agencies, for different, with input from the industry as well as the government agencies, how to make it possible that we really have a proper demo of dynamic spectrum sharing. It is particularly for the lower 3 gigahertz. It's not applicable for 7/8, but for lower 3 gigahertz, that was an effort was initiated there. So with that in background, let us look at what is happening and what's happened in the two bands moving forward. Much of this this description will be familiar to several of you. While you're looking at 3.1 to 3.45 gigahertz, the main incumbent are their federal radar systems. And often these are very critical for homeland defense exercise. There are four main types of radars that we saw when we made a deep dive into the PATS 1 process, which was the report was called Embers report. The four main types of radars were ground-based radar systems that were primarily used for long-range missile and air defense systems. There are a few characteristics that made it either amenable or more difficult to share the spectrum. They of course were stationary, so we maintain certain separation distances, and then the rest of the areas, let's say the spectrum, could be used by mobile networks. But some of these radars were active 24/7, whereas others were active episodically or sporadically. So for the radars that were, let's say, active only episodically, there was a possibility of actually coordinating that when they become active, the commercial networks could relinquish the spectrum, but otherwise they could use the spectrum. So there was a way of sharing the spectrum, a practical way of sharing the spectrum. Then there are ground-based radar systems, and these are typically medium to short range and counterfire systems. Most of the time, they will have very, very limited mobility, means they will be moving around within the military bases and so on and so forth. And these are typically active, say, episodically. But we had to keep in provision that they may be moving outside the bases, and they could be providing services anywhere in the country. The third one was the naval systems. These are again medium to long range missile and air defense systems, and we are quite familiar with dealing with from our CBRS experience, so there's nothing really new to be said there. And the last type of radars were the airborne systems, the AWACS, the long-range early warning systems, as well as the station-keeping equipment, which basically provide the command and control of various systems. And by far, these were the most challenging to share the spectrum with, for obvious reasons. Now, again, most of the time, these pieces of equipment are flying around very planned paths. So again, there is no reason why it cannot be sharing spectrum in a coordinated way. But at the time of national emergencies, obviously they will have to be made, it should be made possible for them to operate anywhere without any hindrance to their operations. So the fundamental approaches to adopt the different kind of radars would have to be very different for the system. But these are the four main ways that you could categorize their usage. Now, just a quick summary of what the study was and what the outcome. There are multiple, several dozens of radar systems that are operating pretty much all over the country that was studied. And essentially what we ended up were identifying what would be the separation distances for different radar systems at different locations that were analyzed during the process. We had, there were some production criteria that DoD and their agents came up with, and based on that, they came up with the separation distances. While determining the separation distances, there were certain capabilities, or they say course of action, that was considered that could be used to minimize those separation distances. And among them, there were three main COAs, as they're called. One was the active 5G RAN sensing. So this would be the commercial equipment will be sensing the presence and accordingly adjusting their emissions based on when the radar is operating and where their radar is operating. That was considered. Then a dynamic spectrum management, similar to say SAS, CBRS system, but in enhanced capabilities because again of the characteristics that I mentioned before. And last one that was also considered was the digital cancellation of the 5G signal. So it is the radar that will develop the capability how to deal with interference from commercial base stations. The fundamental principles that were kept in space were the coexistence cannot result in the loss of access to spectrum for federal agencies and cannot degrade the performance, and they would not consider, say, vacating or compression or repacking of the radar operations. Fundamentally, what it was concluded that whenever the federal systems were operational, the commercial systems could not operate. So there would be a very sophisticated coordination system that would be needed for the two systems to share the spectrum. For the shipboard and ground-based systems, it was a relatively manageable, but when it came to the airborne systems, as you can well imagine, if we allow them to be operating anywhere, anytime, that sharing mechanism coordinate system could be very, very challenging to do. So nonetheless, it requires a fairly, say, innovative solutions. And the demo that is being planned is supposed to be looking into making that a reality, but we'll see how that comes into place. Any questions on 3.1, 3.45 before I go to 7.8? Not. Let's go to 7.8. And this could seem like an eye chart. What we have here is on the x-axis, the different frequency ranges, and the y-axis is the different allocations that we have today. And for each row, the allocation, there are basically three types that are mentioned here. The first, let me see if I can just point out one. That means basically shows where the international allocation, then federal, and then non-federal, just to show you how things match up. Where we see the yellow lines, these are basically Earth to space kind of applications. So these are uplink services, and the blue ones are either space to Earth downlink, or these are say fixed service point-to-point microwave kind of applications. What you see in the darker ones, these are pieces where this particular service is secondary, but the solid ones are really primary services. As you can see, most of the allocations follow the international allocation, except for the mobile satellite space to Earth. This is the downlink service. But here, most of the allocation is actually secondary. This about say 7250 to 7300 is about 50 megahertz is primary, but rest of it is secondary. This is the only allocation that you'll see is different from the international allocation, and similarly for the corresponding uplink as well. So the question is, can this particular spectrum be really used for mobile? And rather than looking at this, we can think of it as a little more of a simplified view. We are really thinking about, say, three main types of allocations. First of all is the fixed service, which has got allocation over the entire band, all the way from 7.125 to 8.4. And there may be a little bit of secondary allocation, but this is mostly used. In order for to do or coexist or share the spectrum, it is between say fixed and mobile service almost impossible. I think the best way for us to think about is some level of band segmentation, and that's also the original thought that was behind looking at it. We'll talk about it a little bit later. But in general, the coexistence sharing is very difficult. However, the links are not that many or not spread all over the geography, then there are places that this part of the spectrum can be used for mobile. So either say geographic limitation or band segmentation, those are the two possible approaches towards making it possible. Satellite and uplink service, I'm not going to spend much. This has been studied, as Erica was also mentioning, for lower, upper 6 and even other bands that is studied. Basic idea is to manage the above the horizon radiations. So basically the same technique will apply for this part of the spectrum as well. So I don't consider that as a significant challenge. However, the satellite downlink is a whole different story. Now think of satellite downlink as two different types of applications. One, where the downlink is primarily going towards Earth stations. And if, again, the Earth stations are not too many, then we can manage separation distances and still use the spectrum in the rest of the geography. But if this satellite service is for, say, mobile MSS kind of service, mobile satellite service, right? Or is a direct to home kind of services, those will be very, very difficult to manage. Fortunately, as we see, there is so the most of the use is really to Earth stations, and I'm going to provide a little more detail later on. But other than this MSS that we have in the middle, of which only about 50 megahertz is the primary, but everything else is secondary. If we ignore this one for the moment, the other services, fixed services, are very much related to Earth stations and space stations. Earth stations are not direct to home or direct to consumer kind of service. Now, just to take a little deeper dive about what are some of the allocations today. These are pretty much all federal allocations on the fixed service. this point to point. A lot of this is actually related to the aviation control, the radio navigation radars connecting them back to the traffic control centers. This FAA has got a lot of links. And there's also some DoD usage of fixed service. It's not all aviation and other, there's not all civil usage, but a little bit of, I would say 20% military use there as well. But what I've been seeing is there is a trend of moving away the links from this part, either being replaced by fiber or they're being moved to other parts of the spectrum in 14 or even 23 gigahertz, especially when the links are shorter. There's a trend of reducing the usage of this part of the and for fixed services. On the downlink, most of the applications for fixed services are there are two types of defense satellites. One is the DSCS, which is primarily a US-centric application, and the other is the wideband gap filler satellite systems, which is a newer part of the system, but we are a part of the global arrangements with other countries as well. There are about 11 such stations are going to be in place. Again, the point here is they are fairly limited in the deployment and the geography as far as we know today. Whether there are more and that has to be taken care of or the planned, those are yet to be disclosed by the different federal agencies. So those are still create some of the possibilities going forward. So as I mentioned before, some of the uncertainty factors are really how many links are there, where they are, particularly for the fixed services. If there is a notion that some of the links, particularly from the lower part 7.1 to 7.7, they could be moved to the upper part, which will mean that the lower part could be more amenable for use by IMT, but also it could increase the density in the upper part. So whether the upper part can also be used or not, that remains an open question. There is also another notion that 6 gigahertz licensees want to move to the lower 7 gigahertz licensees. There is also unlicensed users being moved to that part of it. So there's a lot of moving parts there as far as we know. On the downlink services, again, we do not know how many earth stations are there. Those are yet to be disclosed as a part of the National Spectrum Implementation Plan. And there are also some non-federal EES, Earth Exploration Satellite allocations there. We talked about being able to use it in the presence of Earth stations instead of having a direct to user kind of applications. But one of the applications, as we did not quite find out what you'll see here, it is maritime applications in this part of the spectrum. And there it becomes more challenging, and particularly because it is the ports where these applications are likely to be more present, but around the ports you also have higher population density areas. So that's where you'll need the spectrum more. So you really need to figure out how to manage that. And also the most, I think, fundamentally, that we really do not know how much of MSS is really being used. So we have to. So some of the reallocation will be very, very essential to make the spectrum more available for us. Any questions, comments about 7 to 8 before I move to the last piece? Yes, please.
So in the fixed services, certainly in the US at the moment. People online. Can you hear me? Yes. So with the fixed services, certainly at the moment in the US, we don't have a full specification available to industry of where those links are. But in other IT regions in other countries, they have done some studies and actually some more manual oriented sharing processes with IMT in the fixed services in the 3.8 to 4.2 kind of bands. So I mention this because have you considered that when you say the option for clearing and reallocation has not been studied, or do you mean only here in the US because we don't have that information quite yet publicly?
So what I imply is that sharing in the traditional say of dynamically moving back and forth between the two applications is very challenging. So if we have specific links that we can want to stay away from, that is important, and we do not have that piece of information yet. That's what I meant.
In that particular event, and I understand there are other considerations with some of the other services, but in that particular event, do you see it as daunting to figure out a sharing process, whether it's dynamic or not, given that we have found in other regions and nations that we can, in fact, the proof is that we do have IMT operating, 5G IMT operating in a shared fashion in this sense with some of these fixed services. In the 3.8 to 4.2, it's a different band.
Maybe best to take it offline because I do not see, we can do say coexistence, but not sharing if I,
yeah,
if you
less
talk
of a
about
dynamic component, but there are
coexisting sharing
parameters that are adjusted for
sharing
actual coexistence and sharing in this sense.
Yeah, coexistence, of course. Okay. That's only because we do not have that enough information so that we cannot make even an educated guess whether it will be meaningful sharing or not. But once that information becomes available, then we definitely can make a decision from that perspective.
Might that be an option to simply clearing or simply reallocation? Because we know how long that takes, right?
Well, I don't want to say what could be possible because until we have the info, there is no reason why you cannot have that information. As a part of the implementation plan, that that information will be made available. I think it's best to take a proper informed decision at that point in time.
Fair enough. Thank you, Amit.
Hey, Amit, just need to wrap up in like the next 4 or 5 minutes.
All right. I got late as well. Okay, so now trying to take a quick look at the two bands from an objective perspective, right? Lower 3 and 7.8. So what do we know? The lower 3 has got a good propagation characteristics, very similar to our C band. The 3.3 to 3.4 is already an international allocation, so there is a global ecosystem that it can take advantage of. Another thing is also from a deployment perspective, it is adjacent to the existing band, so you can reuse the existing deployment grid. And also you can think of a roadmap towards an integrated radio system, so it becomes much more efficient from a deployment perspective. On the other side, the flip side of that band is there's a lot of military incumbents. And the expectation is that even if we end up, let's say, with a sharing regime, the restriction that will be put on IMT is going to be pretty significant, unless there is some major changes in deployment that you can know. It is going to be fairly restrictive. Everything that you hear about, there's a lot of commotion about dynamic spectrum sharing. However, we know that dynamic spectrum sharing will not, availability of the spectrum becomes highly questionable. So we'll probably end up with more of a, say, secondary or supplementary uplink, supplemental downlink kind of application, not a primary connectivity. So it may be good enough to provide, say, augmenting capacity, but it cannot be a means for a fundamental connectivity. And if we compare that with 7.18.4, what do we have? It's a significant amount of spectrum. It's not just 350 and maybe even a fraction of the 350 as in the lower 3. It's almost 1.2 gigahertz the spectrum, even if we get say half of it, is significantly more than the other piece. This is aligned with agenda item 1.7, WRC 27. Again, we are talking about a global ecosystem. And as we saw before, most of the allocations or incumbents are within simple geographical areas. So the sharing could be basically a static coexisting rather than dynamic spectrum sharing. We don't have to come up with very sophisticated mechanisms to make the spectrum available for commercial use. But nonetheless, as we mentioned, there are propagation challenges. So site densification could be an issue that you have to think about. There is no particular ecosystem for, say, mobile. So either it has to be brought up from ground zero, or maybe some 6 GHz ecosystem that might evolve in Europe and similar countries that we may be able to advantage of, but that's something it's to be seen how things develop. There are two parallel events that I would like to quickly refer to. We have always known that our DoD, Defense Organization, Pentagon, they've always resisted releasing spectrum for commercial use. But over the last month and a half, we saw a couple of announcements, DoD almost championing the use of spectrum sharing. So there was a statement from the National Spectrum Consortium. They're saying, oh, it is very important for DoD to figure out how to share spectrum, and they're asking for more than $1 billion of funding and so on and so forth. But they do want to make spectrum sharing a reality between DoD systems and the commercial systems. And as we say, the demo, etc., is coming up before the end of the year. So there seems to be a lot of push, a very fundamental change from the position from what you have seen in the past. But at the same time, we also saw an article at the beginning of this month that there are different pieces of spectrum being proposed for commercials, 100 megahertz of CBRS spectrum, 50 megahertz in 1.3 gigahertz range. This is not a in 3GP band, so this is not really helpful from that perspective. 75 megahertz in 1.8. This also may be questionable. 5 gigahertz, that's fine for unlicensed usage, but for licensed usage, that's not really applicable in the US. And then 125 megahertz in the lower, the 7.1 to 5 to 7 2050. So there is no mention of any 3.1 to 3.45 or anything above 7.25, 7.2. There's no mention of this thing. So what is the real position? We do not really know. That's what is DoD really wants to do. Just to if we step back, right? What are the two main options for us to make this spectrum available? On one hand, we're talking a lot about dynamic spectrum sharing. We know how challenging it is just to keep things quickly. There's technical aspects, and there are also the business case or commercial aspects. The technical side, we have to identify whether the radar is active or not, and how do we do that? There could be sensing, there could be notification system. Then you have to do some decision. If the radar is indeed active, what do we do with it? Which are the commercial base stations that has to act, and how do they act, and what is the effect of that action? So all these technical aspects have to be considered. And it is not just a technical solution that we come up with, right? Is there a business case? If we spend all this investment, where is the capital expense, where is the operational expense, and who is really pays for it? How the cost recovery happens? And similarly, if we say the traditional spectrums, like coexistence or clearing kind of approach you look at least at the face value when the stationary federal users, or even that are say intermediate operation, or there's a continuous operation. That could be simple geographical or geographical temporal sharing process. And for the non-stationary, you can think of at least partial packing that may not involve all these complications of dynamic spectrum sharing, big arrangement, and still it can fairly efficiently deliver what is needed. But at the same time, it causes the cost of implementation and relocation. All those things have to be taken. So it is important to take the whole holistic view of the whole business case and not just be focused on one particular solution without the overall picture. The last thing I'll just take away, summarize what we saw is we do see that additional spectrum is really essential for to keep up with the demand as well as to bring in the 6G. We're looking at say 3.1 or 3.45 as well as the 7-8 gigahertz. Just very recently, there was this budget reconciliation bill that was announced, and we're talking about 200 megahertz of spectrum being made available in the next 3 years, 600 megahertz in the next 6 years. We do not know where this spectrum will come from. Right? We're talking about upper C 3.98 to 4.2, but we know that that's going to have a serious restriction on the deployment. And in this bill, you also mentioned that 3.1 to 3.45 has been carved out. So again, what is the position? Is this in or is it not? Even though officially lower 3 is there, but is it really in or not? It's an open question. We see that two bands have very different propagation characteristics, and we need to take a whole view of the techno-economic analysis. That's all I have. Any last minute questions? Yes, please.
Fairly vast set of conversations.
Can you use your microphone, please?
In your broad set of conversations around the world, Amit, have you noticed the use of CBRS and SAS and DSMS with respect to this kind of mixed actual dynamic, temporal dynamism, and the coexistence aspects like we have mixed within the CBRS framework, for instance? Do they make the distinguish that? Do they distinguish those two pieces, or is that something that more practitioners and designers like ourselves think about?
I think there is quite a bit of education still to be instilled. The fact of the matter is this way of thinking is very much started here and is slowly getting some traction at other parts of the world. The only other related thing that I can think of is the hybrid sharing that is being discussed in Ofcom and then spreading to much later other parts of the Europe, where it relates to the upper 6 gigahertz. But it is not, it's still very much in conceptual phase. I would say there's no real practical solution. Thanks. Yes.
Hi, Amit. This is one of the best summations at this time, and you wear kind of a unique hat and role here because you were with the equipment guys and now major operator. With regard to the summation you made, is HDSS viable, do you believe, for Verizon and the other major operators? And if it is or isn't, could you give one or two arguments either way? Thank you.
I would not come to this say whether it is for one, I mean, say operator's perspective or it is, I say, vendor perspective. The proof has to be in the pudding, as they say, right? Can it do what it is supposed to do? If it is really feasible, we have in the technical specification, right, 2017, 26, we have highlighted what are the big challenges there, what are the timing requirements, what are the KPIs, if I may say. We have highlighted those things. Can those really be met? If the solution is there, I think anybody will be willing to take advantage of the solution. but we have to figure out whether the solution can actually meet the practical requirements.
Okay, with that, and thank the speaker.
Thank you.